You probably know the situation. You have a mainboard, you want to change your CPU, you're nervous because your new CPU is so much better than the old CPU, and then this happens. Oh my god, damage on the CPU socket. Today I show you how to repair that. As you have seen, it happens pretty quick. Maybe you just touch it with a fingernail or with something else, and then you see the damage. So we have quite a bump here. And if you look against a light source where all the pins here are reflecting in the same way, you can also see here is something, maybe just a little bit of dirt. Let's turn it over and see if we can see it better from that side. So we clearly see the damage I just made with the CPU. Well, it seems this here is probably just a bit of dirt, but we will see it under the microscope and have a closer look to that and what we can do against it. Today I'm filming through the microscope with my self-made bloggy adapter here. That's an old eyepiece from that microscope, and I attached a plastic plate to it, and then some rubber bands to hold the camera. That's only a prototype. Maybe I will make some better attachments for the camera, but at the moment that works pretty well. And this is how it looks like on the microscope. So I can look through the eyepiece with one eye, and I can also see the picture here on the LCD screen. And what I also need for this job is a set of precision tweezers. They are relatively sharp. No, they are very sharp, so you can make your finger bleed with them. They came in different sizes, some larger tips, some stronger tips, some super fine tips here, and I will use the fine one here to try to fix that socket. Okay, before we start, we need to know how this socket works. So we can see here the individual contacts, and you also see there is a bit of this socket broken off. So I will remove that before it jams something, and I think that piece here is also not on the right place. Yes, it's also a deformed part. That's because the heavy CPU was smashing down on this corner here, but that's not a big problem. So you can see these islands of plastic here, and there is an island for every pin, and you can see in normal conditions the pin goes down into that groove here, and the CPU chip is pressed down by the socket, by the strong springs you have, by the levers, onto this plastic, well, I call them islands here. So this plastic here is where the CPU is pushed against, and the spring is a little bit higher. So when the CPU goes down to the plastic, this spring has a very clearly defined force that touches the CPU pad, the contact pad. Now you see we have a couple of contacts here. Sometimes they hook under each other, so we can simply lift that one up. I think that is still pretty straight. Maybe just move it a little bit in this direction. And you can also see the shine here. This shines because it is now relatively flat, so we have to lift it up. We can check it against the neighbor to see if we have the right angle, more or less. So that's a bad one. It touches, or it's even under the other pin. So if you install a CPU with such a damaged socket, you damage it much more, because you probably crush these springs more than they already are. Okay, I think it's not so bad. Most of them have just snapped under some under the neighbor pins. So that's, maybe I have to check it in another zoom factor. I just realized that's a little bit different with only one eye, because the other eyepiece is occupied by the camera, so I don't have the usual 3D vision here. It's a little bit difficult to judge the height of these contacts. But I think that was already everything. We also see there is dust here, a hair of dust. I can also show you how I clean these CPU sockets. Let's see if we find the other spot that I mentioned. I think it's only, yeah, there's more dust. So the first step would be to use compressed air to blow all the dust away. And then sometimes it happens that thermal paste gets onto the contacts. Maybe I should check the other socket. I think there was a small problem too. I think, oops, let me get my tool here. You can see it. There is something wrong. There is an irregularity in this pattern, something that shines brighter than all the rest. For example, you can't see it so in this direction, hardly, but if you move it, yeah, now it sticks out. There is one pin bent, clearly. And under the microscope, we can see it's two pins here. So we have to move that a little bit to this side. Okay. And we have to move this one. Yeah. As I said before, before we start with any chemical cleaning, we need compressed air or an air blaster can or something to remove all the loose dust here. And then I use a brush like that. It's just a small brush where I cut the hair a little bit so it's more, well, brushy. It's not too hard but also not too soft. And then I use some alcohol, pure alcohol. You can take burning alcohol, or, well, not burning, I don't know how it's called in English, or isopropyl alcohol or stuff like that. Only it has to be clean and pure. You could also take vodka if it's a high percent alcohol vodka, because that's just alcohol and water and not much in it. But, well, I wouldn't recommend it because, well, if your computer smells like vodka, I don't know. Then we have to see where the orientation of the springs is, and I clean one half like this. Take plenty of alcohol and rub it in one direction. Don't rub against the springs because you will bend it. And then you do the same on this side. Always with the direction of the springs. And when your socket is filled up with liquid alcohol like that, you take the compressed air again, blow everything off, let it dry for, I don't know, 15 minutes, half an hour. You can also use a hairdryer to evaporate all the alcohol. And of course you can do the same on the CPU, but here I would recommend, well, no, that's not too bad. So it has a metal hair holder part here, and if you hold it like that, it will be grounded, because you are of course wearing an anti-static strap or an anti-static shoe band. And you can also clean the contacts here. But for the CPU I would normally recommend to use some swabs, cotton swabs. I always do it like that, so you can see if you missed some of the pads here. I always want to say pins, but they are not pins, they are pads. Okay, and that solves a lot of problems, because fingerprints, or if you touch the thermal compound, and then here and here also you have to move it against a light to see the reflections. And if everything looks without any spots, that's okay then. Yeah, seems to be clean. Okay, that's about fixing CPU sockets. And now something completely different. We have been talking about servers, about CPU sockets. Let's talk about server fans. That's a 12 volt DC server fan, 4.5 amps, from a ML350 Gen8 from HP. And I played a little bit with it and I noticed something remarkable. This fan can fly. It actually is strong enough to lift off. And just because you won't believe me that just because I'm telling it to you, I built this little holder here where I can put the fan here on these wires so it can lift by itself. It's just to prevent the fan spinning around like that and destroying my desk and cutting my fingers off, because that spins pretty fast. Okay, let's try it. Let's just hook my power supply on. Black is negative, red is positive, and we don't need all the other wires. There are 3 more wires, like sensor, turn sensor indicator, high speed, low speed switching and all that stuff. We need full speed. I give it 12 volts and maximum here is 3 amps. Oh, I think my power supply is not strong enough. But that's not a problem. I have a triple power supply and I can put the first 2 outputs in parallel, and then I have 6 amps. Positive, negative, just like that. Okay. Let's see what happens when I turn on 12 volt full power. And it actually lifts off. So let's try to give it a little bit more voltage. 13, 14, 15, getting dangerous, 16, okay, I think that's enough. Let's go and land it. 12, 11, 10, 9, okay, that's 7 volts and the Eagle has landed. I mean, really, did you expect that from a standard server fan? That it has enough power to lift itself up? So I think if we cut a little bit of that frame, making everything lighter, we should keep this stator here because that has a big influence on the overall performance. But we could cut away the edges here. We could, cut the wires here, remove the label. That's probably good enough for a bad drone. Not a good drone, but something that probably works. Okay, thanks for watching.